Graphing quadratic functions. You can see our goals here. Analyze graphs, graph quadratic function using key features, and then use a calculator to analyze quadratic function. And we're going to go through the vocabulary as we see the different parts of the function. Okay, so here's what a quadratic function is. On the left-hand side here, you have the general form, ax squared plus bx plus c. And we have some important information about it, where a, b, and c are integers, and a cannot equal 0. And that's because if a was 0, the quadratic part drops out, which is this one, and we're left with just a linear relationship. The curve that you see on the graph here, that is the graph of this quadratic, and the shape of that graph is called a parabola. And you'll notice that this thing is actually symmetrical, and it's symmetrical around a line of symmetry, which I'm going to draw right here. You'll note that this axis of symmetry goes right through the inflection point, which is the vertex, where it changes direction from decreasing to increasing, or vice versa. So that's called the axis of symmetry. And we have a formula that allows us to calculate this axis of symmetry right from the equation or the function itself. And this axis, since it's a vertical line, is defined with x equals some number, some value. Also, it has a point right here where I said that it changed directions. That's called the vertex. And you notice the vertex has an ordered pair for it. In this case, it's 3, 4. And we use the axis of symmetry to find the 3. Then we take that 3 and substitute it into the function up here at the top to find the value of 4. Now you see that this shape goes from left to right. It goes down and has a low point at the vertex, which makes this graph a minimum function, which means it has a low part, and no matter what x values you put into it, it'll never go lower than this lowest part at the bottom. Now, since the vertex has a output of 4 at the low part, the minimum of this function is 4. Now, how can you tell if you're going to be looking at a minimum just by looking at the function and not the graph? Well, it has something to do with this a value out in front. We'll talk about that on another slide. Now, if the graph was shaped this way, and the vertex was up here at the top, then we would refer to that as a maximum function. Now, as far as the end behavior of this graph is concerned, at the top I have arrows on both sides that point upwards, and we would say as x increases or decreases, that means as x goes in this direction or this direction, so increasing is to the right, decreasing is to the left, then y will increase. So the y values are going to continue to go up as you go further left or further right. So how do we graph these things? Well, here's a set of steps that you can follow to graph. Now, the first thing we want to do is determine if the function is a minimum or a maximum. That way we can identify its general shape. Does the U shape go like this, or does the U shape go like that? And the way that we figure that out is we look at this a value up in front. And if a is greater than 0, meaning it's positive, then you will have a minimum function, which means it will look like that. If a is less than 0, then you will have a maximum function, which means it will look like this. So looking at the a value of a function, there's no number there, so the only number I can write is a 1. So this particular function right here is a minimum. Then the second thing we want to do is find the axis of symmetry. Now, the axis of symmetry, as I said, is an equation where we have x is going to equal, and that's going to be the opposite of b over 2 times a. So the axis of symmetry is going to be the opposite of the b value over 2 times the a value. Then the next thing we want to find is the vertex. So the vertex is going to be found by doing the opposite of b over 2a in place of the x value, because the axis of symmetry goes through the vertex at the x position. Therefore, we input the negative b over 2a, and the output will be f of whatever that negative b over 2a comes out to. So in other words, we're going to substitute that into the function and see what it outputs. Now, finding the y-intercept is really easy, because anytime you put a 0 in for x, the only thing that comes out is a y-intercept. And it turns out, in the case of all these quadratics, the y-intercept is always going to equal the c value. So the c value up here is -6, so the y-intercept is 0, -6. Then we're going to use that line of symmetry to find other points and then reflect across, and then once we get points on either side of the vertex, we're going to just connect them with a smooth curve. Okay, so the only way to really understand this is to actually practice one of these. So the first thing, as we said, we want to do is figure out, what is this thing going to be, a min or a max? Well, we look at the a, b, and c values. First thing I want to identify is a, b, and c values. So the a value of this function is going to be the 2 out in front here. The b value is going to be the -8. And the c value is going to be the 2. So since my a value here is greater than 0, meaning it's positive, I have a minimum function. So my graph should go in this direction. It should curve like that, creating a low point. The next thing I want to do is find the axis symmetry, which is based off of this formula right here. So my axis symmetry is going to be x is going to equal the opposite of b, which is -8, over 2 times a, which is 2. Well, this formula will have negative times a negative, which is a +8, and 8 over 2 times 2, which is 4. 8 over 4 ends up equaling x of +2. So now I know my axis symmetry is at +2. I'm going to go ahead and draw that in there. So I have an axis of symmetry that's right here. So somewhere along that line, my vertex is going to be located because I know my vertex has an x-coordinate of 2. So the next thing I want to do is find the vertex. So the vertex is going to equal 2, comma, and then some value that I get out of that function. So you'll notice in this table I have a 2 already. So I'm going to input that 2 into the functions. Now I'm going to replace the y here with f of x instead. So I'm going to do f of 2 is going to equal 2 times, and in place of these x values, I'm going to put a 2. So I'm going to put a 2 in here and a 2 in here, and then I'm going to evaluate. So this first one right here, 2 to the second power is going to give me 4. 4 times 2 is going to give me 8. And then -8 times 2 gives me -16, and then I still have the +2 at the end. And then 8 minus 16 is going to give me -8, and then +2 is going to give me a positive or -6. So I know that my vertex is at 2, -6. So if I go and plot that, I have a dot right here. Now all I really want to do is find points to the left or the right of that vertex. That's where my vertex is going to be. Since 0 is over here on this side to the left of my dot, I'm going to pick points to the left. So I'm going to pick a 1 and a 0 and substitute them in. So in other words, I'm going to pick a value for 1, substitute in output, and then a 0, substitute in an output. And actually I can do that one right now, because if I put a 0 in, the output should be the Y-intercept, which is this 2 up here, the C value, which is 2. So 0, 2. So 0, 2, I'll have a dot right there. Now all I got to do is figure out what dot goes in between the 0 and the 2, which is at the 1. So all I got to do is come back and replace my 2 with a 1 in my function. So I'm going to replace this with a 1, 1, and a 1. So 1 squared is 1 times 2 is 2. -8 times 1 is -8, and then I'm going to add my 2. So 2 minus 8 is -6. -6 plus 2 will output a -4. So I have 1 and -4. And I don't have to come and do these 2 points over here, because all I got to do is reflect. Remember, this is my axis of symmetry right here, my AOS. And since this point here is 1 unit away from the axis of symmetry, its reflected point will be 1 unit away on the other side. So if I were to put a 3 in, the output would still be -4, which is the same as the one on the opposite side of the vertex. Then I'll have the same thing up here. I have 2 units away, so my reflected point will be 2 units away on this side, creating a dot on that side. And I would prefer to have more than 2 points over here. I'd prefer to have 3, but it's not going to fit in my graph, so 2 is enough. And I'm going to end up drawing the best curve that I can. My graph should look something like that, in which the minimum, because I said this is going to be a minimum, the minimum is found at -6. So if I input a 2, the output is -6, creating a minimum value on the function, which is down here at the vertex. Now as far as the domain goes, the domain is going to be all real numbers, unless I put this to a word problem, because I can put any number x going this way and any number of x going this way. But the range is all y such that y is greater than or equal to. Now the lowest y that I'm going to produce is going to be this -6 off to the side, so all my y's have to be greater than or equal to -6. And if I want to put this into end behavior, I can say as x increases or decreases, so as x goes to the right or to the left, then the y values are going to increase because the graph is going upwards on both sides of the graph. For our last example, we're going to interpret a graph of a quadratic function. You can see we have the graph down here, the parabola. And this is representing a horse setting a world record 2.47 meter high obstacle. The path of his jump is represented by this function right here. F of x equals negative 0.48 x squared plus 2.033x. Off to the side, I've already identified the a, the b, and the c values, and the c value here is 0 because he started on the ground, so our y-intercept is 0, 0. And we're going to interpret this as the horse starting on the ground and going up and then coming back down, so the y-axis here is the height above the ground, and the x-axis here is the distance across the ground. They want us to identify a few key features, so the axis symmetry, now remember that is x is going to equal to negative b over 2a, so x is equal to negative, and the b value is 2.033 over 2 times the a value of negative 0.418. And you're going to use a calculator for this, so the axis symmetry ends up equaling x equals 2.43. So find the vertex. So the vertex is at 2.43. That's the axis symmetry, which is the x-coordinate of the vertex. Now I'm supposed to take this 2.43 and substitute it back in for x here and here. However, they already told us that it was a world record height of 2.47, so we already know that the vertex has a maximum of 2.47. So they want us to find the maximum. Again, that's 2.47 meters. We already found the y-intercept. Find the zeros. Well, the zeros are where the graph crosses the x-axis, so we got it down here, and we've got it over here. Now the 0 is actually the x-coordinate itself. The first 0 over here on the left is just the distance across the ground before the horse jumped, which is 0. And then the 4.86 on this side is the distance the horse traveled across the ground through the entire jump. So the zeros are 0 and 4.86. And I use Desmos to draw my graph, so actually it goes to 3 decimal places. Now they want us to describe the end behavior. Now the horse starts on the ground over here and ends on the ground over here. So we're going to adjust our understanding of end behavior with respect to the maximum. So as the graph increases or decreases from the maximum, the end behavior approaches 0. So as x increases or decreases from the max, y decreases to 0. We don't stop at just decreases because he doesn't go through the ground, so he stops at a height of 0.